everybody, this is Dark Husband, also known as the Queen of Missile. For first, start off with, I boosted the microphone a little bit on here, as there were a couple people that commented that the mic was a bit quiet, so we'll see if this works. It's 2.7 increased gain, so it's not really a solid multiplier as far as I understand it, but it might at least make it a little easier to hear this on certain audio devices. Now, I won't be able to kind of get the perfect results with how audio works for these videos, simply because of the way I use headphones. I use open back headphones, so things don't sound consistently the same as if they would be viewed from a desktop speaker or just, more traditional headphones. Anyways, moving into the actual video here, so the plan is to kind of show off the visualization tool that I use for prototyping some of the mathematics behind ICBM. Now, in some past videos, I've shown off various different aspects of this. I've showed off the fact that we can calculate flight paths in this case. It's not exactly clear. I do really want to come back to this at some point and make this a little easier to work with and look at. As the original plan was to actually release this as a way for people to kind of dig into the mathematics and kind of plan out what they're doing with the mod, and kind of from the PvP aspect of, like, I know I need to fire a missile between A and B, here's how the missile's going to behave and do that kind of stuff. But we went through, we did things like accuracy, which you can kind of see this here. The white background really isn't working for this. I definitely need to spend some time here. We even did one for the scaling test and stuff like this one. This is one of the more recent ones, and of course there's even one for the gas cloud to do calculations on how the particles are going to behave, how the pathfinding is going to behave, and everything else. But the part I want to show off is the ray tracing. So in the last video I kind of talked about how we work through some iterations with the Redmatter, and how the plan was to get to something that was really good performance, got good functionality results, without causing tremendous problems or being hard to maintain and everything else. Well, we kind of went through and figured out, okay, where are we at currently? What are the other options we have easily available? Now, the menu here is not easy to see, but Blast Large is what the nuclear blast in the mod originally used. It's basically a modified version of the TNT that has been scaled up, and the algorithm has been changed to allow it to function at a much larger size, as the vanilla TNT actually does have a maximum size limit to which it will stop functioning properly. Now, I have toyed with this algorithm a little bit more, as there was some issues with it. So the nuke is, I think, the only one that actually uses this currently, and it was running into some double ray tracing problems and everything else. So the script has been tweaked from last time we used it. But you can kind of see how it works here. We start off with a center point. We pick some kind of radius. In this case, we have a size of 10. I believe the nuke is like a 30 or not something. I don't even remember anymore. I don't keep track of the math that easily. With this visualization tool, I can kind of sit here and I can look at various things. I can check what the ray traces look specifically like. I can check what the heat map looks like. So the heat map basically tells me how many times has a ray trace gone through a block, because each time you're re-ray tracing through a block, you are just wasting time, because you've already hit it, you've already known that you've hit that spot, you've already run the calculations on it, you've already done all the work you possibly can get it. So the more you ray trace to a spot, the more cycles of the CPU you are wasting. But say if I just want to look at the ray traces themselves, I can visualize that. If I want to see how we're doing the mathematics to detect for block traces, because ray tracing, the way at least it works in vanilla, the way I'm kind of utilizing it, is we draw a line between point A and B, and we iterate through that line segment by segment, going through and going, hey, is there a block here, is there a block here, is there a block here, and so on and so on. So you can kind of see that here, where we have up here on the edge here, where we're doing one hit here, we're doing another hit here, which is actually hitting this block, we're doing another hit here, hitting this block, and so on and so on. So it's kind of weird how it works, but that's what the heat maps for. Because originally when I was doing the streams, because we did a few live streams for this. I know everybody doesn't really tune into those and kind of watch them, but I do go through and actually build these on the live streams, and actually do experiment and toy with them, usually at odd hours during the day. Live streams are kind of weird. That way I usually just go, hey, I'm going to do a video at this time, and don't really think too much through it. But yeah, so the heat map will tell me how we're doing stuff, and then I can toy with the scale. I can say, okay, what does this look like when I want to calculate at a size of 5? I can see smaller ones. I go, okay, what happens when we just calculate a size of 2? And you may be thinking, like, why does it matter for a nuke to be a scaled size of 2? Well, this algorithm doesn't actually work purely for the nuke, even though we only use it for the nuke in ICBM. The thought process is, what happens if I want to go use this for a TNT blaster? What if I want to do a mutation blaster? What if I do, say, a mortar shell hitting the ground? Some kind of explosive down the road that might end up using this algorithm and might want to see how this behaves. And it also helps modpack makers and server owners who may want to spawn the blasts around the map for various different events or reasons. They may want to have some kind of like challenge where you're running through a maze, and if you round this corner, all of a sudden there's a size 1 nuke that goes off that's just large enough to throw radiation out, but not enough to destroy a lot of blocks. So there's also that thought process through some of this. But I can also check performance of how bad this is going to run if we scaled up really large, and how this is going to look. Obviously, we're not going to be able to see this very well without going to the heat map. And by the way, when you see the dark circle in the middle, that tells me we're ray tracing way too much. This also produces absolutely beautiful little images. It's one of the things I really love about visualization. When I originally got hired by the consulting company I was working for, they actually asked me kind of where I wanted to go with things, and at the time I really didn't know. But they had brought up the fact that the company did data visualization. I'm like, hey, if I could possibly get into that, that would be awesome. Obviously, I haven't gotten into that side of things, but it's stuff like this that made me super interested in data visualization, because you could take all of this data, bring it up to this amazing point, and just turn it into something that the eyes can see easily, and let the mind kind of process what's going on, because the raw data for this, you can't do anything with it. You can't really look at that and understand really what's going on. But anyways, this is just a blast here. TNT one, if I can actually select it, because I am using, what is it? Java Swing, I think. So Java Swing is a bit of an outdated UI technology. Main reason I'm using it is just because it's simple and I can make something work in it. I don't have to think it through too much. And when you go to other things like JWGL and OpenGL and stuff like that and try to render stuff, you spend a lot of time with the renders and very little time with actually getting work done. So you can pick a tool that maybe not as effective like Swing, but it gets the work done. So in this case, we're going to test Minecraft's TNT, and this is the part where I was talking about how you run into issues where it doesn't really work at range. So the Minecraft TNT, and I kind of wish I remembered all of the stuff I did on the stream when I looked at this last, because there was a lot of depth I went into debugging the algorithm and actually figuring out how it functioned. I figured out that they do some weird normalization stuff on the algorithm to actually decide how this shape works. Because if you just did a radius shape and you just said, okay, I wanted to have a radius of 3 around this and I wanted to trace out and do all that kind of stuff, you would end up with a circular shape. They did something kind of cool and made it do a box shape here, which actually is not as simple as it sounds, because usually when you're doing stuff, you're going the other direction, not this direction. But they do some normalization that ends up with a square here, and they do some math, and they've got some pre-calculated where they think the maximum TNT ray tracing should actually be, and I don't actually remember what that size is, but I know it was like some value. Actually, what we can do is kind of dig through the code here. All this is open source. If you guys ever want to dig through it, see it, look at it, do whatever you want with it. It is up on, I believe, my personal GitHub repo, which would be github.com/darkguardsman. If it's not on there, it's on the Built Broken one for all the modding. But I think I'm pretty sure it's on my personal one for everything. So the code that should be down in here. We're in the plot panel actually, so I'm in the completely wrong place. So the plot panel is what does all the rendering. Plot panel, grid render. So I've kind of broken this up into a whole bunch of different panels to kind of, I would say, abstract it a little better, but it does make it a little bit more confusing to remember when I'm coming in here months after the fact of remember where things are. Now, obviously, it's probably, I want to say down here. There is some calculations running here, so I'm assuming the walls calculations here. Yeah, these are what we'll look at in a second. Every block calculation. Yeah, there's quite a few different algorithms we'll be digging through here. But the one I am looking for, we can find it. Dot size, line size, clear. Is there a drop-down menu? Because the drop-down menu will tell me. I'm still using string-based drop-down menus, so I really want to like rewrite this. At some point, I think what I'm going to do is I'm going to rewrite it in JavaScript so we can throw it up on a website and have people be able to get into that website and actually run on this. Because as much as Minecraft is Java-based and people kind of would love to continue using Java for things, I've actually personally found it over the last decade to be not the greatest language for a lot of things, including UI work. And I forcibly got kind of introduced into using JavaScript, but after getting over that initial hump of I don't like this because, you know, the memes of JavaScript bad type of thing, which does seep in you, even if you try to avoid it, it does get to you eventually, of the ideal that you get that, build up that narrative that JavaScript is a bad language, when in reality, it actually is really good. It is really solid of a language. It's just, a lot of the examples you see are not good. But if you get into Node.js and you get into ES6, it's really nice. It looks almost exactly like Java, except you don't have to worry as much about, your types. You don't have to worry as much about having like all this strictly typed stuff, and you can do a lot of cool little things. Anyway, so we're looking for the TNT. All of that was mostly me just talking to remember where I put everything. So calculate blast. I badly need to come through and redocument stuff in here. This is how you can tell this application I was building on the fly and not really caring too much. I'm outputting debug. What else we got here? Okay, here's that normalization thing I was talking about. That's part of it right here. Actually, do I have a checkbox in the UI for that? Normalize vectors. Calculate. So yeah, this is what I was talking about. If you actually do some normalization, it actually does change the shape of how this looks. I believe this is the only blast that actually deals with normalization. So what I think Mojang did is they stopped normalizing. Rather, they just didn't apply it. Normalizing basically what you do is you take your magnitude and you're just dividing your step sizes out. So instead of ending up with something like a number of like 5/3 as you're kind of, imagine if you're doing XY coordinates, you're doing like vector stuff, it tries to bring it down to like a between 0 and 1 value. So you end up with a much better thing. But yeah, they do ray traces or rays per axis. So what they've decided is that the value of 16 is where they're kind of heading for. I believe 16, this should work. Oh no, at 16 this no longer does what it's supposed to do. And if you go into a lot of mods who still use the TNT blast algorithm, I believe, slipping me, I know IC2 used it for a good while. It's the reason why their nuke actually had this kind of pattern. And what was the other mod? It's the one that had the planes in it. Flans mod. So Flan mod, a lot of their explosives did this, and I used to play around with one of the tanks that had missile launchers in the back of it. I didn't really use the mod that heavily, but every time we installed it, I would go and spawn some of the stuff and go like, hey, I want to see how this works. And they had a missile launcher one that fired big missiles and would generate this kind of pattern every single time. And I looked at it like, that's a weird and inefficient, and like I'm like trying to look for a functionality, gameplay, lore reason why they did it, and it couldn't figure it out. And then it turned out many years, actually it wasn't even many years, I think it was only months down the road, I finally found out, oh yeah, they use a TNT blast. That TNT blast just happens to do this. I want to say, what is the maximum size we get where this actually starts to work? I actually lately remember doing this on stream of actually sitting here playing around with it. So it looks like, yeah, 6. And I don't remember if the Minecraft TNT is actually set to this size. We actually can go experiment. I don't want to make this video hugely long, but at the same time I feel it actually is kind of useful to share this kind of knowledge and express down how some of the stuff works, how we got to this certain point with functionality, and how somebody else can take this same knowledge I've learned and apply it to their own function. Because honestly, I don't care if people make their own explosive mods and missile mods and whatever. I'm actually glad if people do, because it would provide more alternatives to the users and might mean that either two of things happen. I don't have to work as hard maintaining ICBM, or it motivates me to be a little bit more competitive about what functionality I'm putting in there, so that way my content balances out with everybody else's. Probably a mix of both would be nice. But if we do, I want to say it's Control-Shift-F. Nope, not Control-Shift-F. Control-Z. Oh yeah. Yes, it is Control-Shift-F. I'm just really bad at doing things. So I want to look for, maybe not any TNT. Is it any TNT? Because I want to probably end up finding, if I type in blast, no, it's probably explosive. I think it's what, or not really Mojang calls it that, it's more of just kind of what Forge has named it. It'll be easier if I can actually browse through the code. Here it is. So if we go down in here, was this? No, it went to concrete. Why did it go to concrete even though I clicked? That was really weird. That's how videos end up getting like really long, is when you're messing with stuff like this. Control-Shift-F. Explosion. And because it's coming from, let me, so we know it's net Minecraft world explosion. I mean, I want the actual class, but I can, this is close enough, I can just do this with it. So I want to kind of scroll down through here. Yeah, so we do see 16 down in here. And what is the default size? 'Cause I think that's what we were looking for. Obviously, this is going to be generated by the world. World's not controlling it, so... Well, how it would work is that... These are on client side. So we would be calling the server. Server will be calling new explosion. And I believe this passes its strength. Yep, strength is value. Because what we're basically looking for would be NED, yeah, NED TMT primed. It would do a strength of 4. So if we pass on a strength of 4 into this calculation, that's what we end up with. Which I think feels approximate, because you wouldn't actually have the TNT blast be this large, because it actually does some damage calculations on it. So your center point would be here, it would be going out each iteration. And if we turn on the ray traces, because this is what the actual algorithm looks like, and this is where I said like the algorithm is kind of cool, is that it actually is finding this kind of edge size here, like it's getting that block shape purely by not normalizing the data, and it kind of looks really, really cool. It's really nice result to see, even though the blast as you scale up doesn't really work. Now I can modify this. It's just their blast ends up in having this huge dark circle in the middle that doesn't quite proportionally deal with the fact that as you scale up, you're just the ray trace is getting insane on the size wise. But it ends up really cool. Get this basic shape. As my brain kind of figures out where I was tracking at. Yeah, you get, it'll track out, figure out the damage doing, and if you're doing it like in Stonewall, you would go out and you more or less lose all your energy right away. And if we go pop over to here, I can kind of point out where that algorithm actually is. So do explosion A, which I believe is what actually collects the blocks. I don't think it's actually, yeah. So it figures out what blocks we're going to delete, because it doesn't delete the blocks in this go. It does its ray trace, which in this case we're doing like basically 16 in all sides. It basically says, okay, we only care about the edge blocks. So you either have to be 0 or 15 or something like that. It then figures out how to translate that position out. It figures out the distance. It does look like they actually are normalizing to some extent. I believe this is our energy calculation. Yeah, this is our energy calculation. And you will see this in the ICBM nuke. This is kind of where Calclavi got a lot of this from, is he mimicked what he could find in the existing code, and then just kind of improved upon it and ended up with a different algorithm over time, purely based on what's going on. I believe in the newer versions, this has actually changed quite a bit because it's improved a lot. But you'll see it will figure out the energy, it will go through as it tries to step forward and tries to do that ray trace forward, and it will keep consuming energy as it hits exposing resistance. It'll also do all the checks it needs to do. It also does some little bit of randomization and burns through the energy, and it will collect all the blocks up. And I believe this next step down here deals, I think, purely with entities. Yeah, this is our entity calculation. Then when you do explosion B is when it actually does the damage train, and somewhere between there, either in this step or some other spot, we actually do fire a forge event that does actually ask which blocks are allowed to be destroyed. Because we're adding all here. Yeah, it's probably this right here. I'm not entirely sure if that's the exact spot, because I'm obviously didn't write a script for this video, so I haven't planned this out exactly. But yeah, we do get this for the TNT, and this algorithm, it works. Like for small explosions, this reason why the kinetic explosion in ICBM still uses it, it actually works really well and does end up with the results that we are expecting. But when you start to scale up really large and start to get up to those like huge massive sizes, it ends up with a mess here. And obviously this is really hard to visualize, so let me remove the lines and go purely to the heat map. You can't really do this with a larger size. The way to go around about fixing this, which I'm probably doing a different video, we'll do a different video where we experiment with like toying with this and kind of iterating through different ways to manipulate this algorithm purely on its own to get it to do different things. But let's go over to the next one, which, if I can select it, can I do like a arrow cube? Oh yeah, ray cube. I'm trying to remember exactly what the ray cube was. I think this is where it actually ray traces. Yeah, it just ray traces every cube in the thing. So you get like a pretty consistent, I've just ray traced everything. If we do lines. Yeah, this one was horrible. I actually ran this one in the game and I couldn't keep my computer from trying to kill itself. It was pretty bad, especially when you try to keep in mind that dots are here. Now the good thing with the dots is we really are pretty much just doing a dot per block. And this is even like a perfect representation of the algorithm because the way I've got this built into the visualizer is slightly different than what I did in game. So the in-game version actually was still running the Mojang ray tracer, which the Mojang ray tracer would do a dot per step on this line. So it would actually be even significantly worse than what's being shown here. And then we move down to the ray circle. Ray circle basically just says, hey, let's take the same thing and we'll just make it a circle. Inside the code, if we go and look for these guys, that's TNT blast. There's the large blast. Yeah, this ray trace every block right there. If I go up, badly optimized ray trace per cube, and this is literally the same thing. So 2 and 3 are more or less the same thing. The only difference is one does a circle, one does not do a circle. So, and if we go actually to this code, ray trace as block. Yeah, it's basically just going for every cube. It's looping through, using a bit of a lambda function so I can be lazy, getting the points, putting them on the dot trace. It's not even actually doing a lot of work. It's not even having to work as hard as some of the other algorithms. It's just really there for me to visualize and go, hey, this was stupid ideal, but let's try it anyways to see just how stupid it was. EdgeCube was kind of taking this concept and actually making it work properly. And this is actually what we do use for the ICBM stuff. We don't use the cube, we use... Actually, the walls is what we use. So the cube, if I run the calculations for this guy. Oh god, my computer did not love that one bit. Let's get rid of the lines. Yeah, so this one, you know what, I need to take this down to like a smaller size to even remember how I built this. Take you down here, and we'll throw the lines on here. So this one, I believe how it was built is we were taking dots on the edge, and we were basically going, hey, I know I have a cube. I know that cube is going to go out to a certain size. I'm just going to ray trace between point A and B in a cube-based shape. Pretty straightforward. You get some dots here, get some visualization here. It works. And I believe edge walls is basically the same exact concept. Actually, I'm trying to remember what I did differently between these two. Maybe this is me just trying to perfect the algorithm a little bit. Let's actually dig in there and try to remember what in the world I was doing with this. Okay, so this is the actual ICBM one, which is because that window so I don't get distracted. So we get the wall calculations. I want to say the difference between these two is how the code is actually calculating things. I believe it is actually calculating the walls. It's actually trying to figure out where those walls are rather than what I think the other algorithm does. Is it actually just finds all the positions and just simply traces towards them. So one's more wasteful than the other. Ray trace edge blocks only. Yeah, this one uses it. So they're basically accomplishing the same thing. Just one uses a better algorithm than the other. So this guy, what it did, yeah, it went for every cube. So imagine if you're doing a for loop and you're going from x 0 to 10 and then from y0 to 10. You're going through every one of those indexes and you're just saying, okay, I only want to keep the edges. That's what it's doing. It's doing that same kind of thing, the same exact thing that the Mojang code was doing, and just grabbing the edge blocks, which is very, very wasteful in performance because you have to loop through that, and as you scale up, you're exponentially increasing your amount of iterations you have to go through. It's a time complexity problem. For those who actually know it, in computer science terminology, it would be big O notation of like O n to 3 to the power of 3. So you would always be iterating to the power of 3 of your size, which would be n. In this case, elements is usually what you use n for, but it gets the idea. Like if we're going from a size of 10 to 100, you're scaling up and you're massively increasing. So at 10, you'd be looping, I believe, 1,000 times. I was trying to think of like what was a good example. It'd be better if I actually just use a calculator and not try to hurt my brain at like 5 in the morning. So yeah, if you go to from 10 to 100, you go from 1,000 to 1,000,000 loops. But when you try to do it via an edge, like try to actually make a calculation that does the edge for this, what you're actually doing is, in theory, should be only looping the surface of your cube or circle. In my case, I believe still is doing it as a cube, and I believe the Redmatter still does it as a cube as well. We can check the code in a second. I can pull it back up and we can look at it right before the video ends and kind of get a good diagnosis on here. But we basically do steps. So we go from negative to positive, so we're always going to be that size. So we put a size of 3 to be negative 3 to 3. And we're going to do offsets, which I believe I went through and made a matrix. Actually, yeah, I think it's called a matrix. I don't use these enough anymore that I always forget what they're called. Yeah, so yeah, this is compensation for the fact I don't have enum facing, I believe is what it's called on 112. Offsets. Yeah, so we loop through our sides. So in this case, because we're two-dimensional, we only have 4 sides, and the actual game would be 6. We figure out what our walls are going to be, and we basically just calculate those walls. If we were doing this in a 3-dimensional way, we would obviously be calculating the entire surface wall, which I believe the algorithm in the actual mod is much more complicated as a result. So if we go in here, and I go hunt down the logic, remember, where in the world I even stuck it? It's definitely under content. Now, one of the things we will always run into with ICBM is that the stuff is a mess of legacy mixed with new stuff. And I really want to get down to a more consistent data structure, or package structure, because data structure and package structure, similar words, but they mean different things. Because what I like to do is I like to put all of our content underneath the content package. So name of the mod, or package of the mod, so in this case ICBM Classic, would then be content, all of your content would be under here, and then you stick everything else outside of it, like mod compatibilities out here, prefabs out here, which prefabs, I don't even know why we even have most of those. They're not used much. Data fixers, could be argued, could be content, but I'm getting sidetracked. So we're going to the blasts. Redmatter, which Redmatter is actually really nicely organized. I'm starting to break up all of the code to make it significantly easier to find. So it'd probably be the Redmatter block collector. Collect blocks on walls. So you've seen the same step pattern we were doing, just now we're going to be doing this 3-dimensionally. And we're going to be looping. This code is also unit tested, so I do have automated testing to ensure that this code works, because one of the biggest fears between jumping between versions on Minecraft or long-term legacy maintaining of a mod is that as time progresses, something will eventually just break your code and it will not even be your fault. It could just be some kind of underlying logic change, like say they decided to change the order of how enum facing worked one day for no reason, like in particular, just maybe it happened. Or maybe somebody submitted a PR to Forge and whoever was looking at the code that day wasn't paying attention and introduced a bug. This has happened before with, I believe, the fluid handlers, where we did actually introduce, well, in this case was King Lemming actually did a PR to prevent nulls in the fluid stacks, which actually was important. Like his change was actually good. It's just it got pushed through, which then broke a lot of mods in the process. And it's just kind of changes you always have to worry about, but unit testing does catch extent of this. But we do loop through all 6 sides. And we more or less generate a face wall by just going through and going, hey, here's our offsets. We then apply it to the consumer. The consumer is basically just a Lambda way of collecting things. That way, when I'm working with the code here, in this case, I do have tests for the tester. These are simple tests. Keep in mind, they just have a lot of data. That's what makes unit testing the most frustrating thing in the world, is that it could take you an extremely long amount of time to set up really simple data. In this case, it literally is just wall faces, but it takes you a while to do. But yeah, that is an example of how the code actually does function. If you guys ever want to learn how code works, unit tester probably one of your fastest way. But when it comes to the entity side, if I can actually go back to what I was doing, when the entity actually just fires this off, it'll do the start next block destroy cycle, and it'll just go, hey, here's what size I am, and I just want you to pass this lambda in, which I can't remember if it's on compile time or on runtime, this does turn into a function inside the code. So people who always go like lambdas are slow, they are not. That myth came from the fact that a anonymous class creation was actually slow in older versions, because you were always recreating the class over and over again. But yeah, this will go through there, generate everything, and I think I've covered enough of this. If anybody's got any questions, feel free to ask them down in the comments or on the Discord channel, but I'm going to go ahead and end this video here and go think of what to do next and probably work on a few bugs here. But I'll see you all guys all later.